In this video, we're going to talk about the relationship between the IP address and the subnet mask. The IP address is the value that's going to represent a unique location within the IP system, so you can send and receive information to and from that device. The subnet mask is just a value that we're going to apply to the address to determine what other addresses are in the same broadcast domain, aka subnet, aka VLAN, aka network. So in this particular case, what I've done is I've broken out the IP address into 4 different colors, and I've used the same corresponding colors for the subnet mask. So I've used red and blue and green and gold to show you that there's a relationship between each one of these digits. Now I've further gone to the point where I've listed the values of zeros and ones, the binary values, directly above and below, because on the far left over here, if we were to look at the whole address, on the far left over here, these particular digits on the far left would be in position 1 if we took the whole thing. And if we look all the way over on the far right and we look at the furthest right-hand digit over here, this would be position 32. And every digit in between would be position 2, 3, 4, so on and so forth to 31 and 32. So we're going to line all our digits up and we're going to number them from left to right, position 1 on the left, position 32 all the way over on the right. Now, each block of numbers is separated by a dot, and each block we call a byte of information. The corresponding digit in the IP address to the subnet mask is equivalent to however many digits we're going to use for 2 different values inside of this address. When we apply the subnet mask, the IP address isn't just one address. It's a network address, and it's also a host address. And the way we can determine what the network address is not an official number of bytes that we're going to use for network. And there's not an official number of bytes that we're going to use for host. If you like that model, we use that in LANs for ipv6, where we just do a /64 for everything. And we say, well, there's no way a network's going to be that big. But within ipv4, they said, look, we got 32 digits. And what we can do is we can make big networks and we can make small networks. And the way we're going to do that is we're going to apply a different series of 1s in our subnet mask, and that's going to allow us to create bigger or smaller networks. In this case, this is a fairly small network, and I can tell you that because it has 24 digits in the subnet mask that are set to 1. So if we took these first 3 numbers and we look at this whole piece right here together, that whole piece together is going to be part of our what's called our network value, or a network that we're going to work off of. Why is that our network? Because in order for 2 unique IP addresses to be in the same network, all of the binary digits from 1 all the way through 24 in this case, all of these have to be exactly the same in order to be considered in the same network. How do I know that? Because the subnet mask that we applied is 24 ones long. There's 24 ones followed by 8 zeros to get to our 32 digits. Hopefully that makes sense.